7. Which of the following are the roots of the equation 2x squared plus 4x minus 3 equals 0? And based on the answer choices, I don't think we want to try to factor this, so let's go right to the quadratic equation. I like to start with the discriminant first, so that's the square root of b squared minus 4ac. So in this case, if we plug in, that's going to be 16 minus 4 times 2 times minus 3, all under root. If you do that math, that works out to 40. So the square root of 40 can be simplified to 2 root 10. And now if we put that into the quadratic equation, that's minus b plus or minus the discriminant over 2a. So in our case, minus 4 plus or minus 2 square root of 10 over 4. And now if we simplify this, the biggest number we can take out of all three terms is 2. So that's minus 2 plus or minus root 10 over 2. And that's answer choice A. 8. If g of x equals 3x minus 5 and h of x equals 7x plus 10 over 4, at what point does the graph of g intersect with the graph of h? Well, they intersect when their equations are equal. So let's set them equal and solve for x. And as I write it down, I'm going to multiply both equations by 4 just to speed it up a bit. So g of x becomes 12x minus 20, and that's equal to h of x, which is now 7x plus 10. And now we can add 20 to both sides and subtract 7x from both sides. So 5x equals 30, x equals 6, and we could plug that back into either equation to find the corresponding y coordinate, but only one answer choice has x equals 6, so D is the right answer. 9. If x equals k to the minus 1/3, where x is greater than 0 and k is greater than 0, which of the following equation gives k in terms of x? So let's raise both sides of the equation to the negative third power first. So we get x to the minus 3, and on the right we get k to the minus 1/3 times minus 3, which is just k to the 1. So this ends up just being k, and then we can re-express the left side. So if I say that that would be 1 over x cubed, that's the same thing. And so that looks like answer choice A, and that doesn't break down as a result of these conditions, x and k both being positive. That's not going to interfere in any way with that being true. 10. If the equation shown has infinitely many solutions and c is a constant, what's the value of c? So let's simplify the left side by distributing that negative. So we can say that that's 4x minus 10 plus 2x, and then we can distribute the c on the right side, so we get 3cx minus 5c. And then if we just clean up the left by combining like terms, this becomes 6x minus 10, and no change on the right, that's still 3cx minus 5c. And now if this thing's ever going to be true, then the first order coefficients, meaning the things that are multiplied by x, have to be equal to each other. So in this case, that's 6 equals 3c, and the constant terms also have to be equal to each other. So that's minus 10 equals minus 5c. And it turns out that both of these equations give the same value for c. c equals 2, c equals 2. So that is the value of c that will give us infinitely many solutions. 11. If 0 is less than 1 minus a over 3 is less than or equal to 1/2, which of the following is not a possible value for a? So this is a compound inequality. Let's try to rearrange it so we have just a in the middle. So the first thing I'll do is subtract 1 from all three sides, if you will. So then we get minus 1 less than minus a over 3 is less than or equal to minus 1/2 on the right. And now we have to multiply by negative 3, and that's going to change the direction of all of the inequality signs when we do that. So on the left we get 3, and now this becomes greater than, a in the middle, and now this becomes greater than or equal, and this becomes positive 3/2. And now, just to keep with convention, we may want to write this in the other order since we're used to going smallest on the left. So then it becomes 3/2 less or equal to a less than 3. And the question is, which of the following is not a possible value for a? So a can be anything between 1.5 and 3, but it includes 1.5 and it does not include 3, since this is not a less than or equal. So D, a cannot be 3.